On October 19, 2017, the universe decided to send us a message. Or, at the very least, it sent us a messenger. A small team of astronomers using the Pan-STARRS 1 telescope in Hawaii noticed something quite peculiar. They saw a faint point of light moving rapidly across the sky. At first it might have been dismissed as just another asteroid, one of the countless rocks that orbit our sun. But this object was different. Its trajectory was unlike anything we had tracked before. It wasn't bound by the sun's gravity in familiar elliptical paths. It followed a hyperbola, a clear sign it was passing through from interstellar space. It came from the direction of Vega, but Vega hadn't been there when the object began its long journey. Observing Oumuamua was a frantic exercise against a ticking clock. From the moment of its discovery it was already heading away from us. Astronomers around the globe dropped what they were doing and pointed their most powerful instruments toward this fleeting visitor. European Southern Observatory's Very Large Telescope, Gemini Observatory, Hubble Space Telescope. We were trying to study an object the size of a football field from millions of miles away, and it was getting fainter by the second. It was an unprecedented challenge. Our primary tool was its light. We measured its brightness, and noticed something extraordinary. It changed dramatically and periodically. Brightness varied by a factor of 10 or more every 7 to 8 hours. That suggested Oumuamua was tumbling through space. It implied a very unusual shape, highly elongated, perhaps 10 times longer than it was wide. No asteroid or comet in our solar system has such an extreme aspect ratio. That was our first major clue. We use spectroscopy, splitting light into a spectrum like a prism. Spectroscopy lets us identify surface chemistry. Oumuamua's spectrum was reddish, like weathered outer solar system objects, but the spectrum was featureless. We looked for signs of water ice. We looked for other volatile materials. We found none. There was no fuzzy coma of gas and dust. Despite the world's best telescopes, we never got a direct image. It was simply too small, too far away, and moving too fast. All our knowledge came from points of light and changing characteristics. We were like detectives describing a suspect from a fleeting shadow. Every piece of data was a vital clue, but the picture remained incomplete and baffling. Faced with Oumuamua's perplexing set of characteristics, the scientific community entered a period of intense brainstorming. We needed a theory that could explain everything at once: the extreme shape, the lack of a coma, and the mysterious non-gravitational acceleration. One early idea: Oumuamua was an interstellar comet that had simply run out of gas, or its volatile materials were buried deep beneath a protective crust. But that doesn't fully explain the sheer magnitude of the push it received. A lot of material would need to be expelled to cause that acceleration. Another intriguing hypothesis: Oumuamua was a nitrogen iceberg, a fragment chipped off a Pluto-like exoplanet in another star system. Solid nitrogen is common on objects like Pluto and Triton in our own solar system. A chunk of frozen nitrogen would sublimate and create a jet of nitrogen gas. Because nitrogen gas is transparent, the outgassing would be invisible. This could explain acceleration without a visible coma. It's a clever idea. A more recent idea posits that Oumuamua was a hydrogen iceberg. In the coldest, densest parts of space, it is theoretically possible for solid hydrogen to form. The problem: hydrogen icebergs would be extremely fragile. They would likely not survive the long journey through interstellar space. When all natural explanations for an anomaly are found wanting, it is prudent to consider less conventional possibilities. It is our duty as scientists to explore every hypothesis that is consistent with the data, even those that may seem extraordinary at first glance. This is why I propose that we must seriously consider the possibility that Oumuamua was not a natural object at all, but rather a piece of advanced technology. This is not a conclusion born of fantasy, but one that arises directly from the evidence. I have argued that the most plausible explanation for a small object being pushed through space without any visible outgassing is radiation pressure from the sun. This is the principle behind a solar sail, a form of spacecraft propulsion that humanity is currently developing. If Oumuamua were a very thin craft, perhaps just a fraction of a millimeter thick, its acceleration would be perfectly explained by the push of sunlight. Its extreme shape could be because we were observing a flat, sail-like object edge-on as it tumbled. As I stated in my book, what would happen if a prehistoric cave dweller were to see a cell phone? He would have seen a smooth, shiny rock. The cave dweller would be judging an advanced technology based on his limited context. In the same way, we may be judging Oumuamua based on our limited experience. While the artificial origin hypothesis provides a neat explanation for the data, the majority of the scientific community prefers to seek a naturalistic explanation. The prevailing view is that invoking aliens is a premature leap. The principle of Occam's razor is frequently cited. For many scientists, proposing a new type of natural object is considered simpler than proposing an alien civilization and its technology. The mainstream argument is caution. Extraordinary claims require extraordinary evidence. Critics point out we have only one data point, Oumuamua. Drawing such a grand conclusion from a single, poorly observed object is considered unscientific. The exact shape is not known. It's inferred from the light curve. Other geometries could mimic the same observations. The debate over Oumuamua's nature essentially boils down to a philosophical difference in approaching anomalies. On one side, you have the evidence suggesting an artificial origin. Non-gravitational acceleration without a visible coma fits perfectly with the model of a solar sail. Its trajectory was close to the local standard of rest, almost as if our solar system simply ran into it. All proposed natural explanations require inventing a new class of object with zero independent evidence. An artificial object is something we know is possible. We are developing the technology ourselves. Given the vastness of the universe, the probability of other technological civilizations existing is not zero. Ultimately, the debate is about how we weigh probabilities in the face of incomplete information. Regardless of its true nature, Oumuamua has fundamentally changed our perspective on the cosmos and our place within it. Its most important legacy is that it served as a wake-up call. We now know our solar system is constantly being traversed by interstellar objects. Before 2017, the study of interstellar objects was purely theoretical. Now, it is an observational science. Astronomers are building new telescopes that will scan the entire sky, finding perhaps one interstellar visitor every year. With advance warning, we can plan detailed follow-ups and perhaps one day launch a rapid response intercept mission. The Galileo project is a direct response, searching systematically for physical evidence of extraterrestrial technology. A picture would be worth 1,000 papers. It would resolve the debate instantly. If we see a rock, we learn about planetary formation. If we see a clearly manufactured object, it would be the most important discovery in human history. Oumuamua taught us to expect the unexpected and approach the universe with humility and open-mindedness. Oumuamua was the first messenger. The cosmos is surely sending more. Next time we must be ready not just to listen but to see. The future isn't just about going out there, it's about being prepared for what might come to us. The fundamental question remains, are we alone? We must continue to look up. We must build better telescopes. We must greet the next messenger with an open, curious, scientific mind.